And the tool
Yes.
for discussion is Age R&R, measurement system analysis. First of all, the measurement system, whatever we are using, that should be good. Otherwise, what happens? The data cannot be good. Because we believe in normal distribution, like how all of us believe in God. We all believe in normal distribution and derive conclusions using normal distribution. Only the data is going to confirm whether the process follow normally or not. Only the data is going to tell us how the process is behaving. So the quality of the data is very, very important. So we have to make all measures to ensure we always collect data in an error-free manner. Thereby, our data becomes clean as well as becomes credible and worthy for analysis. Otherwise, what happens? The data will lead us in a wrong direction, right? So that is why we have this particular topic, measurement system analysis. I'm sure you all have been taught already about certain measurement error or certain terminology related to measurement error, bias, linearity, and stability. The bias, linearity, and stability, these are connected to the accuracy of your reading. These are connected to the accuracy of your reading. There is one more thing we need to take care, which is called consistency in data collection. Accuracy in data collection is ensured or verified by looking at bias, linearity, and stability. Since there were absolutely no questions, I strongly believe you have 100% clarity on bias, linearity, and stability. Now the focus is going to be on consistency in your data. When an appraiser is given a job to collect the data, is he consistent? Is he consistent in collecting the data? Is he collecting the data following a standard procedure? He is not supposed to follow his own procedure. He is supposed to follow the procedure given by us. As a result, the data will become worthy, right? So repeat, and the consistency can be understood by these tools, repeatability error and reproducibility error. We are going to understand it by doing a live exercise during which the participation is compulsory, right? All of you need to participate with me. And then I will also teach you the terms called resolution and NDC. NDC must be minimum 5 for any measurement system. NDC must be minimum 5. So what is this NDC? What is its connection with the resolution? We are going to understand. And then what this gauge R&R exactly means, we'll also see the application. It is applicable whenever you collect continuous data. You all know what is continuous data, measurable data, right? So that is what we are going to understand. So every time you collect a data will definitely have variation. Data will definitely have variation. Variation is the problem we want to attack. Hope all of you agree with me. Variation is the problem. Problems are rejections. Problems are product quality is bad. Problems are items not arriving on time. It all because of the variation. So we are trying to address all the problem by controlling the variation. Now variation can come from two sources. One is your process is designed badly. Hope all of you agree with me. Your process is designed badly and variation happens. This is called process variation. This is the actual problem. We are on it. This is your project. Your project is to control the process variation. But when you are actually executing a project in the measure phase, you have to collect the data. When you want your team member to collect the data, they might mishandle the measuring equipment. They might hold the workpiece wrongly, or the measuring equipment could be in a bad condition, or the instruction that has been given to the operator could be wrong. Due to all these things, your data can have some error, can have some deviation, which is called measurement variation. All of you understand both the terms? One is process variation, another one is measurement variation. Process variation is something we want to see, something we want to control. Measurement variation is something which we don't want to see, but it comes. Which we don't want to see, but it comes. Because it is error. It will bring down your visibility on the problem. Hope all of you agree with me. If you allow the measurement variation to populate in a heavy intensity, the situation will, become equal to driving a car by closing the eyes. So please don't create such a situation in the initial stage itself. You must control the measurement variation. Thereby, you can clearly see the problem. You can clearly see the road and drive the car. Similarly, you can clearly see the problem and drive the project. So there are two types of variation. One is process variation. Another one is measurement variation. When I control the process variation, my problem is solved. My company will get good products. Customer satisfaction will be more profit. But when I control the process variation, you know what will happen? I will be able to see the problem clearly. All of you, do you understand? So before controlling the problem, before reducing the problem, you should be able to see the problem. So which one you should do first? Control the process variation or control the measurement variation?
Measurement variation, sir.
Control the measurement variation. Because then only I can see how much is the problem. Otherwise, what happen? If you allow the measurement variation to dominate, you might get a wrong estimate of the problem. So getting a wrong estimate of the problem will sometimes lead to underthinking or overthinking. We need to have a right judgment. So Six Sigma aims to reduce process variation, but MSA helps in reducing the measurement error. First, you should do MSA. Then only you proceed with reducing the process variation. So with MSA, we are actually wiping out the windshield. If we don't wipe out the windshield will be unclear and you won't be able to see the road. So which side is clear? The right side or the left side? The right side is with MSA. The left side is without MSA. If you drive the car without MSA, probably you get a dull blur image of the road and then you can't take right decision, right? So MSA ensures the project team focus accurately on the process variation. This is with MSA. You are able to see the road. You will be able to see the problem accurately and ensure your improvement efforts are used efficiently. Otherwise, what happens? You might think that you are on the road and then you keep your accelerator at the higher level. But actually, you are now out of the road. And that could lead to problems, right? So you can see the conditions better and understand the process conditions better with the MSA, right? That is the purpose of with the MSA. And in MSA, there are two types of study. One is to understand our accuracy. Another one is to understand our precision. Accuracy is closeness to the true value. Precision is consistency in our value. Both are important. Accuracy is closeness to our true value. In order to ensure accuracy, we take multiple reading. Hope all of you agree with my statement. In order to bring accuracy, we take multiple reading. Always, we take 2-3 times we measure and then use only the average. Why are you doing so? To bring accuracy. But when you take multiple reading, it is very important that your readings are also consistent. So that consistency is checked using the precision. That is called precision. And we check precision using gauge R&R. Now, all of you first need to understand resolution. I'll explain. Resolution is nothing but the minimum reading that can come from your measuring equipment. The minimum reading that can come from your measuring equipment. Tell me, as far as the inch tape is concerned, what is the minimum reading that can come? Look at the
1 millimeter, sir.
1 millimeter. You will be able to measure 1 millimeter. Yes, then it is the resolution is 1 millimeter. If you have a problem, if you say, so sir, no, sorry sir, I can't measure 1 millimeter using this. I have got a better equipment. I mean, better measuring device. But I will still use this inch tape for measuring. It is in your hand. If you think 1 mm can be measured accurately, then the least count is 1 mm. right? The resolution is 1 mm. In other words, resolution is nothing but the least count. You all might have used vernier caliper, dial gauge, and many things, isn't it? Everything comes with the least count. What is least count? That is the resolution. A person, at the age of 20 or 20 or 25, his eye has got a better resolution. Am I right? But a person at the age of 90, 95, what will be his resolution? His resolution will be weaker. You need devices with a better resolution so that your vision can be better. Hope all of you understand what is the meaning of resolution. Am I correct here? Now tell me, please, all of you, now I give a small exercise. All of you, please open your mobile phone. Pick up the stopwatch. There is an application called the stopwatch. Inside the clock, there will be a stopwatch. Tell me the resolution of the stopwatch that is there in your mobile phone. All of you, will you be able to do it? Please participate. Go to your phone, open the clock, open the stopwatch, and tell me what is the resolution of the stopwatch that you have in your Android or Apple phone. That will let me understand. Yes, Rajesh. What is your answer?
It is in seconds. Like
1 second. Minimum reading that can come is 1 second. It can't give below.
Yes.
It's 1/60th of the second, I think.
1/60th of a
Second.
Oh, is it so? Are you sure with your answer, Nurul? But it's a good attempt by Nurul.
Yeah.
100th of the second.
1 by
100.
Wow, beautiful. Can we all clap for Nurul? This is what I exactly wanted. I need a clap. Nurul deserves it now. Right? It is not 1 second. It is not 1 by 60th. It is 1 by 100. 1 second is divided into 100. That is why you have 2 decimals, isn't it? So that means the lowest reading that can come is 0.01 second. 0.01 second. I hope all of you have the stopwatch with the same resolution. Am I correct? All your mobile application. We are going to do a data collection today, live data collection. Each one of you should use your stopwatch. So keep it ready. So I can also show my stopwatch, right? So here it is. Let me show mine. 00 and 2 more 00, isn't it? That means seconds and 1 by 100th of a second. All right. So resolution is the incremental ability of a measurement system to discriminate between measurement value. 1.01 is different, 1.02 is different. Suppose like Rajesh said, if the resolution is 1 second, 1.01 is also 1 second, 1.02 is also 1 second. Do you understand the problem now? If the resolution is bad, if the resolution is just 1 second, it will read everything as 1 second. 1.01 also read as 1 second. 1.02 also read as 1 second. Tell me 1.4 second. 1.4 second will also be read as 1 second only. Am I correct or not? So when your equipment rounds 1.4 to 1, it captures an error of 0.4. If the 0.4 is very important to your customer, then you will be at risk. But you understand? So resolution, the better the resolution, better will be your readings. So first equipment gives readings like this, 2.1 and 2.2. Now tell me what will be the resolution from the first row? Resolution for the readings of first row. What is your guess now? Come on, try to answer. I think Nurul has
0.1 is the resolution.
0.1 is the resolution. That's all. That's all. You're right. This is what we discussed last 10 minutes. And for the second row, it has come from another equipment, another measuring equipment. It gives readings in this manner, 2.01 and 2.02. Now, what is the resolution?
0.01.
Which measuring equipment is better now? Row number 1 or row number 2?
Number 2, sir.
Number 2 gives more insight, better insight than number 1, right? So that's why equipment with the better resolution can give better NDC. Equipment with the better resolution can give better NDC. So what is NDC? NDC is the discrimination index. How do you differentiate one from other? Isn't it? Nurul is a different participant. Rajesh is a different participant. Anand is a different participant. I would understand that. The faces are different. If I say all of you are same, then my discrimination is very bad. My discrimination is very bad. Similarly, your measuring equipment should be able to differentiate good part and bad part. Within the good part, there will be different types of good parts. All of you agree with me? Within the good parts, there will be different types of good parts. Certain parts will be too good. Certain parts will be just good. Isn't it? If you want to capture everything, then your equipment should have better resolution, and so it should have a better NDC, which is called a discrimination index, also known as distinct data categories. Once the equipment's resolution is known, you can make a judgment whether the equipment is better or not in comparison to another equipment. We always compare one measuring equipment with other measuring equipment, mainly based on the resolution, mainly based on the discrimination index, right? So look here, there are certain set of readings, 5.1, 5.2, 5.3, 5.4, 5.5. The resolution here is 0.1. All of you agree with me. Resolution here is 0.1. And how many parts are measured here? 1 here, 4 here, 6 here, 3 here, 2 here. Totally, how many parts are measured? How many parts?
16.
16 parts you have produced. All the parts have dimension between 5.1 and 5.5. All the 16 parts have dimension between 5.1 and 5.5. Now you get an idea of the process variation. Am I right? You get an idea of the process variation. Now, how many parts are having a dimension of 5.1? Only one.
1.
How many parts for 5.2?
4.
4. Similarly, for 5.3, it is 6. 5.4, it is 3. And 5.5, it is 2. So you produced 16 parts. The 16 parts fit into any one of the 5 category. Suppose if the customer requirement is 5.3, how many parts are too good?
6 parts.
6 parts are very good with respect to the customer requirement. So you are now able to differentiate. Of course, customer is okay from 5.1 to 5.5. He is going to accept everything. But 5.3 is too good. But 5.1 is too bad. Within, is just bad. Sorry, just good. So that means now the NDC is 5. Now the NDC is 5. Within the range of the products you produced, there are 5 categories exist. How do I know 5 categories of products I produced? By calculating NDC. All of you, do you understand NDC here? Please confirm.
Sir, can you please repeat again?
So there are 16 readings. Finally, all the readings fit into any one of the 5 category of values. That's all. Even when I end up producing 1,000 units, all 1,000 will fit into any one of the category only. Because I never produce below 5.1. I never produce above 5.5. Right? And now I check all the parts using a measuring equipment, having a resolution of 0.1. All my readings will definitely be any one of the 5. All of you understand? You have to keep talking, right? This is why, we are trying to create a habit for all of you. Every day morning, you must talk. At least you should say, something when we meet. Then only now also you can discuss. So any data you collect using a measuring equipment will either be 5.1, 5.2, 5.3, 5.4 or 5.5. That's all. Do you think 5.115 will come? 5.15 will not come. Why? Your equipment resolution is 0.1 only. If I use another equipment, its resolution is 0.05. What is the resolution now? 0.05. It is not 0.1.
0.05.
Now between 5.1 and 5.2, you will have a chance to record 5.15 also. Am I correct?
Yes, sir.
Because the resolution is now 0.05. 0.05 is better than 0.1. As a result, between 5.1 and 5.5, you might now get 9 readings. Am I right?
Yes.
NDC has now improved from 5 to 9. Why? We have used a equipment with a better resolution. Suppose if the resolution is 0.01, now tell me how many readings are possible between 5.1 and 5.2?
More than 10 readings.
Yeah, more than 10 reading. 5.11 possible, 5.12 possible, isn't it? No, NDC will in every range you will get 10. NDC will become close to 50. So having a better NDC gives better information. Am I correct now? Better resolution makes your NDC better. So now this is a simple example you have understood very easily. Even if the situation complicates, if your data has a lot of decimals, then also you will be able to calculate NDC using this formula. I kept a discrete number of values to make the explanation simple. But when I bring a lot of decimals here, let us say 5.1023, so many things are happening here. In that case, you can calculate NDC using this formula. That is when your data is continuous, you can use this. Sigma of parts, sigma of gauge. For that, you must understand what is sigma of parts and what is sigma of gauge, which I will be explaining. Shall we proceed now? Are you good with NDC?
Yes, sir, I can proceed.
The industry requirement is NDC must be minimum 5. If NDC is less than 5, the equipment is straight away unfit. 5 in the sense between your preferred range. Whatever range within which you want to collect the data, in that range, NDC should be minimum 5. Now I want one of you to read out the definition of the term repeatability. Then we will talk about it. Repeatability. Can one of you read out the statement repeatability?
Repeatability is the consistency of a single appraiser to measure the same part multiple times with the same measurement system. It is related to the standard deviation of the measured values.
Thank you, Mr. Anand. So what Mr. Anand is saying now, repeatability is the consistency of the single appraiser. Let us say Anand is the appraiser. I want Anand to measure a product. Let's say I have a product like this, a wooden block. I want to know the diameter of the wooden block. And Anand has got a vernier caliper. Now he will use the vernier caliper and tell me the diameter of the wooden block. Just if he takes one reading, I'm not very confident of the reading. So I expect Anand to take multiple readings and calculate the average and figure out what is the dimension of the wooden block. Am I correct with my idea now? Because wooden block, can have some cylindrical issue, isn't it? It can have a different diameter. Am I correct or not? So I take multiple reading. 3-4 readings he will take, and then the average of the readings will be now considered as the diameter. All right. And now when Anand is taking multiple reading, I expect all the readings, to be same, because I expect all the readings to be same because I'll give Anand a exactly cylindrical block. If the block is exactly cylindrical, what does it mean? Diameter will be same at throughout the length. Can I say like that?
Yes, sir.
So now Anand is taking 5 readings. What should come? All 5 places, same diameter should come. If Anand actually produces same reading for for all the 5 different points along the length, I will say Anand readings has repeatability. That's all. That's the definition. That is what he said. He read. Do you think repeatability is required or not?
Required.
Required, because the product is same. The product is same. He measures 5 times. Why do I measure 5 times? I require it. I wanted to be sure. I wanted to be doubly sure my readings are perfect in guiding me. So same part, he measures multiple times and the readings are same. Then only I will consider him consistent. If he gives me different readings, then I will start doubting Mr. Anand. Anand, what is this? I gave you just only one part. The diameter is same everywhere. And you are taking 5 readings, but 5 readings are different. But already I know the diameters are same. You know why? Because it is a standard part. Because it is a standard part, reference part. Same part, same dimension. Only thing is measured multiple times. If the readings are same, it is called repeatability. All of you understand the meaning of repeatability?
Yes, sir.
Let us say the diameter is 30 mm. Anand gives 5 readings, 30, 30, 30, 30, 30. All 5 readings are 30. Is he consistent now? Consistent. How do I know? There is no variation in the data. All are 30, 30, 30, 30, 30, 30. All are 30. So there is no variation. If there is no variation, calculate the range. One of you, tell me the value. What is the range? Come on. All the readings are 30.
0.
What will be the range now?
That is the range, sir.
Range is maximum minus minimum.
0.
One,
0.
one.
Since all are 30, maximum is also 30, minimum also 30, range is 0. When the range is 0, Anand is highly consistent. Am I right? When the range increases, let us say one of the reading becomes 32. Now what is the maximum?
2.
32 is the maximum, minimum is 30, the range is now 2. If you allow the range to gain value, you can understand Anand is slowly becoming inconsistent. All of you agree with me? So range is a measure of variation, which you can use it when the number of data points are less than 8. All of you understand? When to use range? Range is a measure of variation when the number of data point is less than 8. If the number of data point is sufficiently more, better and more than 8, standard deviation should be used as the measure of variation. Now read the statement. It is related to the standard deviation of the measured value. Do you understand the meaning now? Repeatability is related to the standard deviation of the measured value. Anand has taken 5 readings. Range is 0. If range is 0, standard deviation will also be 0. When standard deviation is 0, he is repeatable, he is consistent. Other words, the repeatability error is 0. Is all my statements correct? Is repeatable, he is consistent. Otherwise, repeatability error is 0. Why do I say repeatability error is 0? Because the range calculated from the data is 0. Standard deviation calculated from the data is 0. So now do you understand the statement? It is related to the standard deviation of the measured value. Repeatability is related to the standard deviation of the measured value. All of you, do you understand?
Yes, sir.
Now I want one of you to tell me the relation. What is the relation between repeatability and standard deviation? What is the relation? You now understood. Related. What is the relation? If standard deviation is increasing, what will happen to repeatability? Come on.
Average,
Repeatability will be reduced.
That's all.
Inversely proportional.
Inversely. When the standard deviation increases, repeatability will decrease. When standard deviation is decreasing, repeatability will increase. I hope all of you also very clear now with the difference between repeatability and repeatability error. Am I right? Repeatability is good, but repeatability error is bad. Agreed? Fine.
Yes.
Sir, I have a doubt here. So repeatability we need to do with a single person, or we need to do with the multiple?
Single person. Single person. Repeatability is a term related to single appraiser. Good question. Very good question.
Okay, thank you.
So I think now.
Sorry, sir. Sorry for the
Yes, please,
interruption.
please. Most welcome. Yeah.
The reason in our process we are measuring the gauge RNR, but we are measuring with the entire team. So we are giving the similar samples to everyone, and we are measuring how they are performing, and based on that we are taking the refresher, or we are educating the team. So this is the method. It is correct, or we need to make any changes?
No, it is correct. It is correct. What you are doing is correct, because like repeatability, there is one more error called reproducibility error.
Okay.
In order to capture both forms of error, you must involve individual appraisers. You must involve individual appraisers. You should also involve all the appraisers.
Okay, got it, sir. Thank you.
So reproducibility is the consistency of different appraiser in measuring the same part with the same measurement system. It is related to the standard deviation of the distribution of appraiser averages. Now I have cylindrical block. Let us say I have 3 cylindrical block. All the 3 are same. All the 3 are same. I gave 1 to Mr. Anand, 1 to Mr. Rajesh, 1 to Mr. Nurul. What is the standard reference value of the block I have? 30 mm. All right. Now Anand is giving me a reading. Rajesh is giving me a reading. Nurul is giving me a reading. What is the expectation? All the 3 readings should be same. Am I right? Yes or no?
Yes, sir.
Yes.
Because I gave same product. I have same product, exactly same. Only thing is I did not tell them in advance. I asked them to measure separately. Now all the 3 are giving the same reading. Now
So sorry,
the
sir.
team is
So sorry, sir.
yeah.
Sir,
Now
here the components are same and instruments are same. Only the person is changing, right?
yes, everything else is same except the appraiser.
Okay,
That
sir.
is the reason why the readings are same. Now the data is considered to have reproducibility. Your measurement system is considered to have reproducibility. So what is measurement system? Measurement system involves an element called appraiser. Measurement system involves an element called the measuring device. Measurement system involves the element called the part that is getting measured. Am I right? Measurement
Yes,
system
sir.
involves the instruction that has been given to the appraiser, which is called operational definition. I believe that was taught to you.
Yes, sir. The environment, sir, can we consider?
The measurement system also includes the element called environment.
Yes, sir.
Out of all the elements, few elements or majority of the elements are controllable. But the environment you cannot control, isn't it? That is uncontrollable. Any of the element that is uncontrollable, you must consider as environment. So you have nothing to do with the environment. If you can't control, then try to control your readings by effectively controlling the controllable element. Do you understand what I'm speaking? Simple English, right? Because you have control only over certain element. Don't waste your energy, by trying to control the uncontrollable, because it is uncontrollable. Leave it.
Okay.
Right? So focus on the controllable element. You can improve the appraiser. You can provide him training. Am I right?
Yes.
You can improve the operational definition.
Yes.
If the person understands only Hindi, you can give the statement in Hindi only. You can give a picture. You can show him a video.
Yep.
Measuring equipment can be well calibrated, well maintained. All right. And then the part, the standard reference. The standard part is maintained in a condition that it remains standard part. Right? So this is how See, we are trying to understand the capability of our measurement system in giving us an error-free reading. Two types of error possible. One is repeatability error, which is inconsistency in the readings provided by a single appraiser. Another type of error that can come is reproducibility error, which is inconsistency in the readings when we involve multiple appraisers. All right.
Yep.
So when I compare one appraiser reading with other appraiser reading, if there is a difference, that difference is the problem. That problem is called reproducibility error. What I need is reproducibility. What I don't need is reproducibility error. If there is no difference, or if the difference is less, I consider my readings are reproducible. If the difference is big, unacceptable, the error is called reproducibility error. Hope all the statements are clear.
Yes.
Now we are going to do an exercise. I want people to participate, right? We are going to collect data and understand how the errors are going to populate, right? So during this exercise time, we'll switch off the video, and again we will switch on the video for the discussion. So I just pass it. So with the activity, we have understood one thing, reproducibility error. And now I'm going to reveal one secret. How many songs I played?
3.
3 songs.
Songs are same or different?
Different.
Different.
But the duration of the songs are same. I did not reveal this information earlier, am I right?
Yes.
The
Yeah.
duration of the song are kept same. This is how you should also conduct the gauge R&R study. The appraiser should not know the characteristics in advance. Appraiser should not know that they are measuring the same part multiple times. I kept it, confidential. Do you understand? Actually, Anand thought that he heard 3 songs, but I gave him the same part 3 times. Look at the readings given by Anand: 57, 56, 60.12. For all the 3 songs, what is the original value? 60. Same part measured 3 times, but 3 different readings. Now there is an error within Anand's reading. The first row now carries an error called repeatability error. Do you notice, all of you? All of you, do you understand what is repeatability error here?
Yes.
Now tell me, look at Rajesh reading and tell me whether there is repeatability error there or not.
is
Error is
there.
there, but
Yes.
some minimum.
It is there, but compared to Anand, it is better, right? It is less.
Yes.
So Rajesh is doing little better, than the other appraiser. So that is what we could understand. But there is some error. When will I say there is no repeatability error? When all the 3 readings are same.
Yes.
And now similarly, the Nurul's reading, he has, he too have a better repeatability for the second and third reading, but not with the first reading. So there is a repeatability error. How about Sagir? Is there a repeatability error?
Yes.
So all of them will sum up. Am I right? There is a repeatability error caused by Anand, Rajesh, Nurul, Sagar. The overall sum is called total repeatability error. All of you, do you understand?
Okay.
Similarly, all the 4 together, there is a reproducibility error in the first column. There is a reproducibility error in the second column. There is a reproducibility error in the third column. Now, how do I measure the reproducibility? Now, 3 readings given by Mr. Anand all came from same product. Am I right?
Yes.
Now, can you calculate average of the 3 readings from Anand? Possible? Let me say the average is, let me put a rough
58.
value.
58.12.
Very good. Thank you.
12.
Thank you for the quick answer. Similarly, can I get the average of Rajesh, Nurul, and Sagar? All of you, please calculate and let me know. Now, average of Mr. Rajesh.
59.24.
59.24. And then the third one, Nurul? Give me a number. Are you calculating, Nurul?
For Rajesh, it's a correction 59.53. For sorry, right only. Nurul, it is 59.69.
Nurul, it is 59.69. Okay. Then Sagar?
59.20.
Very good. Now, I could clearly see a difference in the average values of the appraiser's reading. Anand gave 3 reading. Since the part is same, I calculated average of the three readings. Similarly, average of the Rajesh reading. Similarly with the Nurul and Sagar. Now, can you notice a difference between the averages? This difference between the averages is actually called reproducibility error. You don't have to work with the individual reading. You work with the averages to calculate the reproducibility error. Hope it is clear to all of you. How to calculate the repeatability error and how to calculate the reproducibility error. The reproducibility error is carried in the variation among the averages. So I calculate a standard deviation using the appraiser average. That will give me an estimate of reproducibility error. Similarly, when I calculate the variation horizontally, like the first variation given by Anand, that will be repeatability error by Anand. Second row, that is repeatability error by Rajesh. So somehow I understand how to calculate the repeatability error and how to calculate the reproducibility error. Hope it was clear to all of you now. What is repeatability error and reproducibility error?
Sir, when we need to do the repeated error, sir?
When we need to do
the repeated analysis at what?
repeatability error, right?
Yes, yes.
See, always you should, when you are doing the measurement system analysis, you should do both repeatability error analysis as well as reproducibility error analysis. That is why we call it gauge R and R, not just gauge R. It is gauge R and R. R and R stands for repeatability and
reproducibility.
Can I come in, sir?
Yeah, RK sir, please add.
Now, gentlemen, suppose Shivakumar asked me to give a lecture to you. Now,
Okay.
today I'm giving a lecture to you. Tomorrow I'm giving a lecture to you. The lecture should be same, yes or no?
Yes.
Right? So that is called repeatability. Right? Now, today I'm giving the lecture. Tomorrow he is giving the lecture. The lecture should be same by him as well as me, yes or no?
Yes.
That is reproducibility.
No, my
When should you
question
have
here.
repeatability? When the
Yes,
same
sir.
person is involved, repeatability is involved. When 2 or more people are involved, then you have reproducibility involved. Okay.
Okay, sir.
In
Yeah,
measuring the same thing in the measurement system.
Like it's a good point. When you involve multiple appraisers,
It is
reproducibility should also be
reproducibility.
calculated.
Yes.
The moment you involve appraiser and multiple readings, multiple reading means same part measured multiple times. Then you should measure repeatability. So both will populate always in many situations.
Sir,
There will be repeatability error, there will be reproducibility error. So you must measure both. And that's why we have the gauge R and R. See here.
let me add a point, sir.
Yes, sir, please.
Let me add a point, please.
Yeah,
Please take down in a piece of paper whatever I say. 3 statements I will tell you. 2 or 3 I will tell you. And that 3 are very important, like Bible. Repeatability is important, number 1. When the repeatability is not there, reproducibility will certainly be not there. When reproducibility is not there, certainly accuracy will not be there.
Very good point.
Okay, these 3 lines immediately wrote down. It is very, very important in your lifetime. Thank you.
Sir,
Thank
please
you.
repeat once again.
Repeatability, if it is not there, reproducibility cannot be there. If reproducibility is not there, accuracy can never be there.
Very good. Good statement. Perfect. Very, very helpful.
Okay,
See
so
here.
repeatability is the first time only we need to do. Reproducibility we need to do it multiple times.
Please
That-
note, it is not the question of first time or second time. Suppose
Okay, so
tomorrow he is
the-
asking me to give a lecture and day after tomorrow he is asking me to give a lecture. Now that time can I have repeatability error?
Yes, sir, my question here is if we are running the process, okay, so we have the bunch of people.
Hmm.
So in during that time, so
Hmm.
when I need to do the repeatability, when I need to do the reproducibility. Reproducibility we are
Please
usually
understand.
following.
No, 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 no.
Please
And,
note,
That
please
is,
note.
I
Once
am
again, let me
relating to
ask
my
you.
process,
No.
so that's the reason I'm asking this question.
Manikandan,
Yes.
answer my questions. When there are more people, is there one person involved? Yes or no?
Yes,
When there are 4 persons, certainly one person is there. When certainly one person is there, certainly repeatability has to be considered. Yes or no?
that comes into the reproducibility, right,
No,
sir?
no, no.
So
That comes only to repeatability. You are considering only one person. Out of the 4 person, consider one person.
please understand, Manikandan.
okay,
We are estimating the error. We are
okay,
not calculating the actual error. See, error, we know that will be a tedious process, calculating the actual error. I am only estimating the error. Estimation is I simulate, collect data, and try to figure out how these people will work well in advance. I should be happy with them. Then only
Okay.
I will involve them in the data collection. I am doing a research. I want to appoint you as the data collector for me. I will only do a small study with you, whether you are repeatable or not. Yeah, if I'm happy with you, then I will consider you as one of the appraiser. Similarly, since multiple so much readings are required, I involve multiple appraiser. And now it is also important that you align with the other appraisers also, and other appraisers align with you, and all of you align with my requirement. Isn't it?
yes,
Agreeing with the team will bring reproducibility.
okay.
Consistency in your readings will bring repeatability. Vivek sir, you want to add something here?
First, you start with one person, then 4 persons, then with the standard. This is in order. Never
Yes,
forget
yes,
this order.
that's what my doubt is. Yes,
Start
ma'am.
with one person,
Yes,
then multiple persons, then with the standard process, standard item.
yes,
So that actually gives us, correct me if I'm wrong, another aspect also, that is about the precision, that is about the accuracy, how close it is with the standard, right? So
Yes.
maybe one hypothetical situation that the standard is 60 seconds, everyone measures it around 64-65 seconds. So there is a less repeatability error, there is a less reproducibility error, everyone is measuring 64-65, but still it is far away from the standard.
standard.
That means it is not very accurate. So that brings us, and that is why RK sir has mentioned 3 statements, right?
Yes,
So ultimately we need to have the accuracy as well. That means how
Repeat.
close the whole bunch of observation is near to the actual value. And this again, as GSK has pointed out, is only an estimation.
okay,
Yeah. So ultimately, we want our reading to be accurate. Accuracy is closeness to the true value. If you are away from the true value, you call it bias. Your bias is more because there is poor reproducibility.
reproducibility.
Your bias is more because there is poor repeatability. You have more reproducibility error, more repeatability error, and as a result, there is more bias. So, in order to control the bias, we all have a remedy. What is the remedy for bias?
Reduce the variation.
Equipment calibration.
Okay,
Equipment calibration and maintaining the equipment in the good condition. But in spite of calibrating, in spite of maintaining the equipment in good condition, still your readings can become useless if you allow the repeatability and reproducibility to dominate. We never measure error in real time. Please understand. We never measure error in real time. We just estimate the error before using the equipment. Once we trust it, we trust it completely and then proceed. You understand, Manikandan? Don't confuse with your real-time usage of the equipment.
okay,
When people are using the equipment in real time, you can't go and control every single minute. It is not possible. Do a study. Take allot 1 day, 2 days. select some parts randomly, select some appraiser randomly, and try to explore, allow them to collect data and study whether they can do a good job or not. If they can do a good job, use them in your project. If they are not fit, you should consider doing some improvement. It can
Yes.
be changing the appraiser, it can be recalibrating the equipment, isn't it? It can be cross-verifying the standard pieces you have used. Do you understand, Manikanta, now?
Yes, yes, sir.
Ultimately, the error, gauge R&R, which is inclusion of both repeatability error and
Repeatability and
reproducibility error, should be less than 10%. That we
Okay.
will understand in another 5 minutes.
Okay,
See
sir.
here, from the data, you can calculate sigma. From the data, you can calculate sigma. There is a repeatability error. You use the readings produced by a particular appraiser. Use only the readings produced by the particular appraiser. Calculate a sigma out of it. Calculate a sigma out of it. For example, Anand has produced 100 readings. Using the same part. Same thing. And now out of the 100 readings, whatever is the variation, that is called repeatability error. So you calculate standard deviation using the readings produced by single appraiser. Same way, every appraiser might have produced error. And now combine everything, that will be the sigma of the repeatability. Sigma is standard deviation here. Same way, my average, Anand average, Rajesh average, and then Nurul Islam average, and Sagar Mohit average. Likewise, the averages will also differ. Calculate a sigma out of it. Calculate a sigma out of it. That will capture the reproducibility error. Now you need to combine both repeatability sigma and reproducibility sigma. Since it is sigma, since it is standard deviation, it can it should be sigma doesn't have no sign. So you should always square them, add them, and take the square root, and then only you will be able to combine sigmas. All of you understand? When I combine the sigma, this will carry information about both repeatability and reproducibility. All of you are clear with me? The overall error that your measurement system can bring is this much. This is particularly the standard deviation of the data, the standard deviation that is seen in your data. Now you multiply this standard deviation by 6. This will give you the estimate of the error that can happen if you allow the team to collect data. If you allow the team to collect data, 6 multiplied by sigma of the error will be the total estimate of the error. How do I get an estimate? Why 6 here? When I go for 3 sigma on the right, 3 sigma on the left, what can happen? 99.73% of the events that are going to happen, I will be able to capture. This we have studied from normal distribution. Am I correct?
Yes.
If I allow the team to work and collect data in real time, many things will happen. 99.73% of the events I can understand by going up to control limit. When I go up to control limit, how many sigmas will be there? 3 sigma. 3 sigma on the right side, 3 sigma on the left side. Right or left, it is an error. Am I correct?
Yes.
Right or left, it is an error. So 3 on the right, 3 on the left. Totally 6 sigmas will be there. Sigma is the error, and there are 6 sigmas. So 6 times sigma will give you the estimate of the total measurement error, which is summation of repeatability error and reproducibility error. All of you, do you understand? We will be diving deeper on the same subject in the next level of the course, right? Because we don't want to confuse you too much. So now this is how you can calculate. And now this can be given a new term, new terminology. 6 times sigma of the error is also known as precision. Also known as precision error. The precision error, you need to compare against the customer provided tolerance. Customer gives USL, LSL. Am I correct? Yes or no?
Yes, sir. Yes, sir.
The difference between USL and LSL is called customer tolerance. compare this precision error against the precision tolerance. In the examination, you have scored, 72 marks. You have scored 72 marks. And what is the total mark for the exam? 100 marks. So 72 out of 100. Now you understand the real meaning. Same way, the error is compared against customer provided tolerance. Now you will be able to understand how much error you have committed in comparison to the tolerance. In comparison to the 100 marks allotted, you scored 72. Similarly, in comparison to the customer provided tolerance, how much is the error you are committing? So compare the precision against tolerance. Now this is called precision tolerance ratio. All of you, do you understand? Yes.
Sir, could you please repeat one more time, sir?
Precision error. See, the numerator is the error in the form of repeatability, in the form of reproducibility. We also multiplied by 6 to get the overall total error. The total precision error we may commit is compared against the tolerance. Within the tolerance only our process is going to operate.
Agree.
All your readings are going to come in this. Now you are comparing the error estimate against the range of the tolerance or range of the limits given by the customer. Now this is called precision tolerance ratio. The other name for precision tolerance ratio is gauge R&R.
Okay.
The other name for the precision tolerance ratio is gauge R&R. This gauge R&R value should be less than 10%. Otherwise, what happens? There will be heated arguments between you and your customer. You will say the product is good. Customer will reject the product. You will check and send the product to the customer place, which is 500 kilometers away from your factory. After receiving the product, customer will check and send your entire lot. Will it be a problem to your business or not?
Yes.
You also checked it. Your quality inspectors have checked it. Now the entire lot of products reaches the customer site. Now the entire lot is coming back. This is called type 1 error. Why the type 1 error is happening? Sorry, this is called type 2 error. I'm sorry for that. This is called type 2 error. Because you have sent the product, but customer says it is defective. If you send a defective item to the customer, the error is called type 2 error. Which will be very costlier, isn't it? Yes. The transportation is lost, the item produced or waste, and there are a lot of problems. Type 2 error, consumer risk. Similarly, one more problem can happen. Your own quality inspector can reject good products within your factory. Possible or not?
Yes.
It's possible.
Now now the manufacturer is under risk. That is called a type 1 error. If you allow the measurement error to increase, the type 1 error and type 2 error will also increase. Your cost of poor quality will increase excessively. If you are truly concerned about reducing the cost of poor quality, if you are truly concerned about your customer relationship, wanted to avoid the arguments, you must ensure the measurement error is less than 10%. Still you have not eliminated, please note, still you have not eliminated. You are only controlling it. 10 to less than 10% measurement system is acceptable. 10 to 30% conditionally acceptable. More than 30% never acceptable. In order to better appreciate the conditions, you should have a good knowledge about control limit. Hope all of you have a good knowledge about control limit. Am I correct?
Yeah.
If the control limits are overlapping with the specification limits in your company, you can only rely on the first statement. All of you understand? If your control limits are close to the specification limit, you should use only the first condition. Don't take advantage of the second condition. Many people don't tell this secret. I am telling you. If your control limits are close to the specification limit, you need to leave only here. Don't use the condition. Don't take advantage of the liberty given. The second condition says 10 to 30% of the error is acceptable conditionally. You can use subject to the condition that your control limit is well inside. Your process is doubly capable. which is nothing but the Six Sigma process. If your process sigma level is not 6, you must stick to applying only first condition. Many people misinterpret this, saying that if the equipment is costly, then it is conditionally acceptable. That is only, a situational remedy. It is not the technical remedy. All of you understand my statement here? But in any condition, more than 30%, the measurement system and the data collected is considered useless only. Please throw away. Whether you are doing an improvement project or you are doing a big hardcore research, the data collected is considered an useless data and it deserves throwing into the dustbin, right? Hope all of you understand. And so heated arguments with vendors and your suppliers can be avoided by ensuring the gauge R&R is less than 10%, right? And see here, the customer tolerance are given. Upper spec. Yes, madam.
Sorry to interrupt. Your screen is not in presenter mode.
Oh, really?
Yeah.
How it is then?
It's in the normal mode only, but it is fine.
I think I'm able to present. It's going well. Okay now?
Yeah, it's fine.
All right. So upper spec, lower spec, target value. And now I am just drawing something. Can you see gray area? Can you see gray area here?
Yes.
Gray area is called zone of uncertainty. Here only problem comes. Here also. This gray area is called uncertainty zone. This zone is called conformance zone. Conformance zone means no problem with the decision. But this gray area, problem with your decision, leading to type 1 error, type 2 error. Non-conformance zone means here also no problem with the decision, but your products are clearly getting rejected. Here your products are clearly getting accepted, but here unclear acceptance and unclear rejection happens. Good product is rejected and bad product is accepted. That is problem. Why this is happening? Due to the gauge R&R. And now, and see here, the customer requirement is 100 plus or minus 0.5. Your product dimension is 100.45. When the 100.45 is the actual dimension and your appraisers are measuring, and now due to the error, 100.45 is now recorded as 100.55. Now tell me what will be your decision? You accept the product or reject the product?
Reject the product.
You reject it. But what is the real dimension? 100.45. 100.45 is inside 100.5. Customer is ready to accept, but your own quality inspectors are rejecting. Now, what is this error? Type 1
Type 1 error. Type 1 error.
Type 1 error. So this is otherwise called manufacturer's risk. The manufacturer is under risk because of the error. That is why it is important for us to control. Why this is happening? Your production process is poorly designed. Sigma levels are bad. Look here, you produce everywhere. You produce everywhere. Where should you produce? You should produce around the target. Am I right? Very first day, RK has made a statement. Takuchi says deviation from the target is loss. Where is your target? Your target is here. But where are you producing? Far away from the target. As a result, type 1 error is happening. So don't produce in this manner. Try to produce like this. Can you all understand now?
Yes.
Now the second condition becomes applicable to you. What is second condition?
Control limit.
10 to 30% error also tolerable now. Why? You have now additional tolerance. Do you understand? Earlier, there is no room for additional tolerance. You have occupied all the tolerance. Your process is just capable. 3 sigma process. CP/CPK equal to 1. Now the process is doubly capable. 6 sigma process. CP/CPK equal to 2. Now even an error of 10 to 30% is now acceptable conditionally. Though it is unpreferred, still acceptable because type 1 error will not happen. Type 2 error will not happen because you are producing here only. Even if something wrongly you place here, still the decision is not going to get affected. Right? That is the advantage of having. So this is a gauge R&R study report using Minitab. I'll explain this after your coffee break. And if there are problems understood, you should be too good in reading the graphs. Histogram, the first one is bar chart. This is a control chart. This is another control chart. This is called dot plot. This is called box plot. This is called interaction plot. If you are really good in data collection, really good in graph interpretation, you will be able to figure out the root cause. You will be able to bring down even the gauge R and R, right? That we will be discussing little later after the tea break. So I stop here so that we can go for a coffee break and come back. So shall we all take a picture for today? Attendance.
Yes.
All of you, please confirm whether my Minitab screen is visible to you.
That's visible.
Yeah. Now, in the Minitab, there is a stat option. Stat, quality tools, gauge study, or not gauge study. Yeah, gauge study. Can you see something? Create gauge R&R study worksheet.
Yes, sir. Yes, sir.
First of all, you should create this worksheet. And now, number of parts. My recommendation to all of you here is to type 10 here. Minimum 10. How many parts minimum you should say? You should have 10.
Minimum.
I have played only 3 songs. I could have played 10 different songs. I could have played 10 different songs to get a better estimate of all your capability. But due to time concern, I reduced it to 3. But you have to have minimum how many? 10 parts. And then number of operators. How many operators we kept? 3. And it depends on, this is a sampling.
Yes, appraiser, 3 appraisers.
Yeah. This is sampling. Depending on the number of appraisers that may be involved in the real time. If in the real time also there are only 3 appraisers involved, involve all the 3. Isn't it? If there are 300 people, anybody can collect the data for you. Then you have to believe in the sampling technique. And all of you please note again, sampling technique is a big area, which we will be throwing light again on day number 5. All right. So number of operator 3 is a good number. And then number of replicates. Number of replicates are nothing but replicated experiment. Replicated experiment means conditions remain same. We repeat the experiment. What is replication? Condition remains same. We repeat the experiment. Minimum there has to be 2 replicate. Then only you will be able to calculate repeatability error. Do you understand why we require replication? If there is no replication, you will not be able to capture repeatability error. So it can be 2, it can be 3. Let me say 3. 10 parts, 3 operators, 3 replication. Now one of you tell me how much is 10 into 3 into 3?
90.
90. 90 readings will now be produced. How many readings? 90 readings will now be produced by conducting the gauge R&R study. What is our intention of collecting the 90 readings? We wanted to take a decision whether this measurement system is capable or not. Whether the measurement system is adequate or not. Please understand, once again, I'm telling, we are not estimating the actual error. We are not calculating actual error. We are only estimating how much can go wrong. How much can go wrong. It is only inferential statistics, right? So give OK. Now the gauge R&R worksheet is created. You all can see now. Automatically created. How many rows added? 90. In this order, you conduct the experiment. This is called randomization. Randomization will minimize the bias. One of the important principles is randomization. First experiment will be using the part number 9. First experiment will be using the part number 9, using the appraiser number 1. Now the data will come. You understand, all of you? First data is now arrived. Let us say 30.52. Now how many experiments we have conducted? 1 experiment. Likewise, you have to conduct 90 experiments. All of you, do you understand how to conduct the gauge R&R study?
Yeah.
Same part by the same appraiser. What is the part number? 9.
9.
Who is the appraiser? Number 1. Same part by same appraiser. Is it happening? Same part,
No.
same appraiser. Can you see here? 31st experiment and the first experiment are same.
Replication.
This is called replication. Since we mentioned 3 replication, there will be 3 times that is happening. 9 and 1.
Sir, some disturbance is coming. Some voice is coming. I don't know where.
Okay, I have muted. So the same 9 and 1 might be coming again. Yeah, definitely. Yeah, here it is. So 67th experiment and the 31st experiment and first experiment are same conditions. And the readings will have variation, which is called the repeatability error committed by operator 1. All of you, do you understand? Now, once the 90 readings are available, let me get a data file so that I can show you how you can actually complete this. Go to project data. Here you type gauge R&R. There is gauge AIAG because AIAG is the organization that gives all all the guidelines, Automotive Industry Action Group. So the reference data is available. Now you all can now see the reference data, right? "90 readings are available. So same setup. Now how to conduct the analysis now? How to calculate gauge R&R? Go to stat, go to quality tools, come to gauge study, and now there is a study called gauge R&R crossed. Crossed means same product is used for all appraiser. Do you understand? Same product used for all appraiser. How many products we selected? 10 parts. The 10 parts I will measure, you will also measure. Same 10 parts will be given to you. We are sharing the part. That is why the study is called crossed. All of you understand? If my 10 parts and your 10 parts and the other appraiser's 10 parts are different, but all of them are standards, then we will go for nested. Now we go for crossed simply because the products after checking by me will come to you. It's a crossed study. Let us say the testing is destructive testing. Do you think that my test piece will come to you? It won't come.
Yeah.
Because I have destructed the piece. Now you have to take a fresh piece. Now the assumption is both pieces are same. That's the time you should go for nested. Now it is crossed. So click the crossed and now tell me which column contains part number in your spreadsheet. I mean in your worksheet.
C1.
So select that C1. Operator information C2. Select that. Where is the data? C3. Select that. Now there are 2 methods, ANOVA method, X bar R method. X bar R chart, right after the discussion, I am going to explain. So let me choose X bar R. Both are okay. You can choose. And gauge information, anything you wanted to say, gauge name. It is gauge XYZ. Gauge name is gauge XYZ. Date of study, it is 15th October. And reported by your name. Whatever is the name you want to give, you can give. And some gauge, if the gauge comes with some tolerance, you can mention that. Plus or minus 0.005, something like that. And now all these things will appear in your report. Now you give okay. Once again, you give okay. Can you see the 6th graph which I have told you? What is the purpose of the graph? Purpose of the graph is root of the problem. Purpose of the graph is root of the problem. Root can be appraiser, operator 1, operator 2, operator 3. Am I right? One of the root cause is operator. Another root cause is operational definition. Another root cause is poor equipment. Another root cause is the product that is given, that is studied. Am I correct? If the product which you give, the standard piece itself can have a problem. All these things can be corrected by referring to the graph one by one. Right? You need to spend more time with us. Right? So I'll be sharing certain videos in our group. Please go through. Also explore the Wednesday class. Also explore upgrading you in the earliest point of time. Because the more you delay, what happened, the more the tendency will be more for you will forget more. So you need to you should be very good in reading all the graphs so that you can actually figure out the root of the problem. Now let us go to the statistical analysis report. This is called a session window. Here is the gauge R&R study report. And see here, whatever I typed, now it is appearing here. Gauge name, XYZ, date of study, all those things are appearing. So this is called the report, gauge R&R report. Now in the report, there are two columns, two tables. First table is here. The first table, I am going to write something here. This is based on variance. All of you, you know variance? All of you know variance. What is variance? Square of?
So difference.
No. Variance is square of standard deviation. Variance is square of standard deviation. And now there is one more table here. This is based on standard deviation. According to the standard deviation only, we studied. What we studied? Gauge R&R should be less than 10%. Do you understand? So this rule is based on standard deviation. So don't refer this first table. Please refer the second table because the rule what we studied is based on standard deviation. Now, in that table, the first row straight away gives a value. What is the value it is giving? Total gauge R&R. How much it is? How much it is? Read out.
26.6.
26%. Now, what is the conclusion?
It is away from the
conditionally acceptable. Your measurement system is conditionally acceptable.
Yes.
Measurement system is not so strong. You have something, but conditionally acceptable. I have given the technical explanation when to accept. If you think the condition of the equipment or the equipment cost is too much, so we should accept. These are all only assumptions, not the real approach. The correct approach is you should have the process knowledge. You should know the position of control limit with respect to the specification limit. If you are very sure your process capability is very high, you can tolerate the condition. If your process capability is weak, your measurement equipment is unacceptable. Do you understand? Though the rule says conditionally acceptable, I am not going to accept. You know why? My process capability is weak. My process capability is considered weak, even if it is around 3 sigma. If it is around 6, I consider capability as strong. Under such conditions only, I will proceed with the measurement system which my company is having. Otherwise, I will be directed in the wrong direction. Right? The data will not be credible. And now, out of the error, which is more? Repeatability is more or reproducibility is more? Please read the second row and third row and tell me which is more.
Reproducibility.
Reproducibility is playing more. The team agreement is a bigger problem than agreement within the operation. So how can you bring the team to a common agreement? Can you give me some idea? All of us have to have a same understanding about Six Sigma. How can we do it? We have to spend quality time. We all have to work in the same manner, isn't it? Same way, team reproducibility can be enhanced by having, giving an instruction which everybody should understand in the same manner. That means your operational definition should be so simple and to the point, so that everybody can understand in the same manner. And there has to be uniformity in the equipment. There has to be uniformity in the equipment resolution particularly. And then there has to be the uniformity in everything, and give training to all the members at the same time. All these things can bring down reproducibility. If you bring down reproducibility, what will happen to gauge R&R? That will go down. All of you understand?
Yes.
Now repeatability. Repeatability you want to control. Repeatability comes from individual operator. 3 operator you involved. Go to the control chart. Go to the control chart. Figure out which operator is troubling more. Which operator is troubling more? Why he is having the trouble? Go and help him. Repeatability will also come down. All of you understand now? But we really have to dive deeper now onwards. And now this gives a picture of a broader picture of part-to-part variation, and this 26% gives a picture of measurement variation. Please understand, since we are working with the standard deviation, the 96 and 26 will not sum to 100. 96 and 26 will not sum to 100 because our calculations are based on standard deviation. If you want to have a proper tallying of the numbers, you must learn to use the first table. Can you see here? Gauge R&R is 7% and part-to-part variation is 93%. Total is 100%. It is tallying here. But then why are we referring this table? Though there is a small confusion because the guidelines are based on standard deviation. Is it clear to all of you?
But how this 26.68 has been arrived?
That you have to work with the data. You have to calculate manually, and that will be a lengthy process. Maybe it will take 1 hour for you to sit down and do it. So you can learn it at a later stage. Now rely on gauge R&R.
Okay.
We need to tabulate the data in a particular manner, calculate the standard deviation, and then, as I told, you have to calculate sigma repeatability for all the operator, sigma reproducibility, then combine, then all the values will come and we can teach you. But then first you digest all these learnings, then worry about manually doing yourself. Right now you rely on the Minitab. So Minitab will give the report.
Okay, fine.
That is what is called the higher level. We will gradually do it. All right. Now there is something written here. Number of distinct categories. Nothing but your NDC. Minimum 5 required. And here NDC is 5. Your measurement system is conditionally acceptable. And the condition you should decide. So this is what I would like to share with all of you as far as the gauge R&R is concerned. And definitely much more learning will happen on the same topic by revisiting the tool at the next level, right? So I take a pause here as far as the gauge R&R is concerned. But however, I would like to encourage questions on the same topic. Any questions? Please ask. We are available. Myself and Dr. RK, we can answer.
Sir, in a repeatability, so if in the first 3 instances I am getting the same results.
Okay.
Can I proceed further or can I stop?
How many readings I suggested here in the example?
Close to 10.
90 readings I told. No?
Yes, 90.
So you should also have conducted 90 trials and then look at the repeatability, reproducibility. If the gauge R&R value is less than 10%, you can trust your measurement system and then allow your team members to collect the data, and you can also trust the data. Got it?
Yes, sir. So my doubt is why we are getting the same answer, right? In the first 3 instances. That is what my doubt is.
No, 90 readings are required. 90.
Minimum 90 is required.
One second, sir. Let me, sir. Please note, the life is full of philosophies. This is also full of philosophies. I'll ask you a question. Your son is there. Your son is has to take the +2 examination, final examinations. But model exams are conducted. 3 exams are conducted. He has scored 90. Will you keep quiet? Then will you not follow him up? Oh, he has scored 90 marks in the 3 tests. So will not bother. So you score 95. Will you score 95? No.
No, not possible.
Always there is always what is called the calibration chart is every often we are doing it. Every year, why are we conducting a test? Every often, why are we conducting a calibration test? You know what is calibration test little like later, right? Therefore, this is a continual process in which whenever there is a problem coming into picture, immediately you question the repeatability of the operator, reproducibility of the team, and then the accuracy of the standard. Right.
Manigandan, lesser the data, poorer will be the prediction. We don't want you to come to a poor conclusion.
You are the king. Only you can tell 3 will do or 4 will do or 90 will have to do.
3 is really, a very smaller number of trials. So I have suggested 90. 90 can also become small.
Okay.
Right. So it depends on the understanding of the situation. Sometimes I may advise you to go for 120 experiments.
Okay.
So it all depends. And but for that, you need to really deep dive into topics like sampling techniques, and another one is sample size.
Okay.
And measurement error is another thing. That is what we are now mastering. But in order to make our conclusions always close to reality, we should be very strong in controlling the measurement error, arriving on the optimum sample size, arriving on the optimum sampling technique. These are the 3 areas, but generally these are taken very lightly. Another thing is, even somebody take it seriously, they understand poorly. But if you really come out very well in terms of measurement error, sampling size, and the sampling technique, you will be an excellent researcher. All your predictions will happen in real time. Whatever decisions you take will always hold good for your company.
Okay, we need a wider range of the samples. Thank you.
Because we're estimating the
Always,
problem.
always
So I must have a wider range.
Always follow a structured way, logical approach, and apply expertise of knowledge in your field. All the 3 are important.
Okay, thank you, sir.
All right, so we will stop the gauge radar discussion here. Now we move on to the other tool, control chart.